Electric charge is distributed over the triangular region D shown below, so that the charge density at the point x, y is given by sigma of x, y equals 2xy measured in coulombs per square meter. We're asked to find the total charge on the region D. If you look at our notes below, suppose an electrical charge is distributed over a region R on the xy plane, and the charge density at the point x, y is given by sigma of x, y, then the total charge over the region R is given by this double integral. So in our case, the total charge Q is equal to the double integral over the region D, this triangular region, and sigma of x, y is equal to 2xy, and then we have differential A. Now let's focus on D, the region of integration. Notice how the three corner points of this triangular region would be the points 2, 0, 2, 4, and 0, 4. And therefore the line containing this side of the triangle would be x equals 2. This side would be in the line y equals 4. Now for the line containing this side, notice how the vertical intercept would be 4, and if we go down 4 and right 2, we'd be at this point on the line, and therefore the slope of this line is negative 2. So the equation of the line containing this side would be y equals either negative 2x plus 4 or 4 minus 2x. Now differential A is equal to either dx dy or dy dx, which determines our order of integration. And let's use dy dx, so we'll integrate with respect to y first, then with respect to x. So with respect to y, we want to see which equations bound this region above and below. Notice how this region is bounded below by y equals 4 minus 2x. So 4 minus 2x is a lower limit of integration with respect to y. It's bounded above by y equals 4, so 4 is the upper limit of integration for y. Now that we have the region bounded above and below, we integrate with respect to x. Looking back at our region, notice how we start at x equals 0 and stop at x equals 2. So limits of integration with respect to x are from 0 to 2. Now let's go and evaluate this on the next slide. So we first integrate with respect to y, treating x as a constant. So the antiderivative is going to be 2x times y squared divided by 2. So again, we have 2x times y squared divided by 2. We can simplify the antiderivative. 2 divided by 2 simplifies to 1. And now these are limits of integration for y, so we'll substitute these values for y and then find the difference. So when y is equal to 4, we would have x times 4 squared. And then when y is equal to 4 minus 2x, we'll have x times the quantity 4 minus 2x squared. So here we'll just have 16x. And here we're going to have minus x times the quantity 4 minus 2x squared is going to be 16 minus 16x plus 4x squared. Now simplifying inside the parentheses, we have 16x, and then we're going to have minus 16x, and then we'll have plus 16x squared, and then we'll have minus 4x cubed. Notice how here 16x minus 16x would be 0. So now we have the integral from 0 to 2 of just 16x squared minus 4x to the third. And now we integrate with respect to x. So we'll have 16 times x to the third divided by 3 minus 4 times x to the fourth divided by 4. Let's go ahead and simplify this. We have 16 thirds x cubed minus x to the fourth. So when x is 2, we have 16 thirds times 2 to the third minus 2 to the fourth, and then minus, notice when x is 0, these will both be 0. And this difference here comes out to 80 thirds, which would be approximately 26.6667. Again, this is charge, so this would be coulombs. So again, this would be the total charge over this region, given the density function sigma of x comma y equals 2xy. I hope you found this helpful.